Okay guys, hello. Am I audible? Somebody please reply.
Sir, it's audible.
Okay, fine. Uh, let's start the session. My name is Satyavikram Pratap Singh and I am PMRF Research Fellow at Department of Energy Science Engineering IIT Bombay, and this is the TAC for the course Smart Grid Basic to Advanced Technologies, whose instructors are Professor N.P. Padi sir and Professor Premlata Jana ma'am. So for starting the uh, session will be like that. The few theoretical concept I will explain to you. Then after few numericals will be there, and we will deep down to some extra knowledge kind of things. Means what are the commercial loads are actually being fed and what kind of power quality issues and how the smart grid actually work. So my screen is visible to you all. My screen is visible.
Yes, sir.
Okay, fine. Starting from the first slide, as you can see, this is the single line diagram of the basic power system network. As you all know, if you have a background of the electrical engineering or related fields. So as you can see, the initial point is the generation, that is the generator which are there. Then the voltages which is being generated is a very high level. So for the transmission, it is stepped down to a certain level which is at a transmission level, that is up to the 132, 220 and the 400 kV level. Then the at a particular levels there are a multiple kinds of consumers are there. Suppose there are a industrial kind of consumers are there, commercial consumers are there, and the household consumers are there. So their requirement of the power level and the voltage level are totally different. So you need a certain in between mechanism to step down or step up the voltage in between. So after the transmission level, there are the very large consumers are there which take this high voltage level for their work. Then it is dropped down to the sub transmission level, so at a level of 66 kV from the 132, 220 and 400 kV to 66 kV, that is the sub transmission level. Then there is also a large consumers are there which is 66 kV level, and there is a primary distribution system. There are medium level consumers who take this 33 kV and 11 kV system for their utilization. And last come to the secondary distribution system, that is the small consumers, that is the 230 volt and 400 volt systems are there. So this is the basic single line diagram, that is the top to down flow of the power, how the power will flow, that is the from the generation to the particular in between consumers or to the last level consumers, that is the secondary distribution level. That is the basic power flow. If in between session, if you have any doubt, you can open your mic and ask me. This is a kind of learning session for you all, for solving your numericals and for building your theoretical concept. So in between, if you have any doubt, open your mic and ask me. Okay, I am here to help you all. Okay. So moving to the next slide. Here focus is let's focus on this secondary distribution at the last level, that is the small consumers who are consuming the 230 volt and the 400 volt level. So here this is the household load. I have given the two figures which I have taken from my home itself in the laboratory, and this is the first image is the current waveform of the LED trim light type of loads, and the second one is the current waveform of the fan type of load, that is the BLDC based motor fan. So if you see what a conventional power system engineer can think of, that voltage, the three phase voltage should be something like that, that is the sinusoidal voltage with a 120 degree phase shift, and the current should also be at a same level. But the what makes this current waveform to a such a point of level, because what you want actually you want a sinusoidal waveform of this nature, somewhat of this sinusoidal level, but the actual what is coming is like that, which is not a sinusoidal waveform, which is somewhat a triangular waveform. So it means that there is a certain power quality issues are there, power quality issues, which is measured in somewhat terms of total harmonic distortion. If you have any doubt, you can ask me in between. Suppose this is the total harmonic distortion or why the sinusoidal waveform, you can always ask. Okay, so this is a kind of a power quality issues to the grid, actually not a because there are a multiple numbers of household consumers are there, and a study said that there is a 60% load which is being consumed is by the household consumer. So this kind of waveform is very prominent in the our household load conditions at a particular scenario. So I want to ask you all that what causes this waveform to distort at such a level, because it can be a sinusoidal, no? Suppose if a resistive load is there, so if you can say you are feeding a certain voltage source, so you can say that this is a current will be certain sinusoidal divided by R. It can be a sinusoidal waveform, but it is not a sinusoidal, but it is somewhat a distorted triangular waveform. I want to ask you all that is what causes this this distortion to happen in this type of load. If anyone can unmute yourself and reply.
The capacitive elements, inductive elements, something in the load.
Yeah, actually that is fine, because the conventional loads are something kind of the RLC kind of load, but that causes the reactive power and phase shift to a certain extent, but not a such type of distortion in the load waveform. That is if you see the capacitive element, that is the I is equal to V by XC minus JXC, it can shift to a minus 90 degrees shift positive or lagging to a current waveform, and if there is a combination, then can be a cause. But this kind of waveform is very prominent due to the power electronic converter based loads, power electronic converters, that is the switching loads. So this means that the what current waveform you actually consume initially, it was a less than 5% TSD level, but due to this power electronic converter based trim lights, fan type of loads, it is increased up to a 30%. So it is a issue. Why I am telling this all to you all this? Because if you see that this is a completely unacceptable, because why? Who can say that this is unacceptable? It means that there is a certain set of standard will be there. Who can say that this quality of waveform is not acceptable? Okay, so it means that there is a certain standard set by the certain authority, so that this TSD, the power quality issues, can be avoided. So coming back to our main topic, by giving the power quality issues, what is happening in your consumer type of load, this is the basic comparison between a conventional grid and a smart grid. So coming from this smart hierarchy, first hierarchy, that is the traditional based systems. If you can see, this is a nuclear power plant which is given, and this is the coal based power plant, thermal based power plant, and other type of power plants are there, where the production is happening. Then for the marketing, because you have to send to the consumer levels, for why you send that? Because you want to make profit and you want to make a reliable system, electricity to all. So the in between the market plays a major role, then the transmission happens, then distribution, then the consumer. If you see, there is a centralized kind of system is there. A center is something, a center part, there is a something, and at that point every nodes are connected. because if you see there is a different kinds of nodes are there which is connected to a central system. This system is known as a centralized, that is the most regional kind of power control. This is centralized, and after that they depend upon the large electrical lines and the pipelines for transmission, and there is a one-way communication. Because why one-way communication? Because you get the electricity from these power plants and you pay the bill for this electricity, but you don't have any control to manage or reduce this power quality or anything, reducing the losses or making profit kind of thing. So this is only one way of communication in the traditional grids. Moving to the right side, if you see here, I have shown the very small power processes, such as this is the PV based power plant, a small hydro kind of power plant, or there is a wind power plants are there. And this kind of system is a decentralized crossing boundary. If you see there are multiple nodes are there here. The larger circles which I am circling with a black, this is a central part, and it is connected to the other sub nodes with a certain branches which are in a decentralized fashion. Means the control is given to the multiple authorities. Control is given to the multiple authorities for the controlling of the power flow from the generation to the load. Okay. So in between, the consists of a small scale distribution and provisional supply settlement system, such as the batteries for the backup and other sources. This is the two-way communication. Two-way communication, why I am saying that? Because you have a proactive involvement in this system. How? You can install the PV panel at your home and you can sell that power to the grid. Now the power flow is happening from a lower section to the upper section. It means that you are sending power to the grid. This is the two-way communication happening, and two-way power flow is happening. So this is the more advanced, that means that this is a more smart kind of grid. It is said as a smart grid. This is the basic comparison between the both system, that is the conventional and the smart grid. If you have any doubt, you can ask me in between. I am here to help you, okay, for the healthy discussion in between us. Okay, you have any doubt, open your mic and ask me. Okay, moving to the first slide. Let's take an example of the EV, electric vehicles. Because why I am taking the electric vehicle as an example? Because it is a very booming field. Booming field in my sense that very much research is going on this EV field, and a lot of job opportunities are there in the EV field. So I am taking the example to relate you with the current scenario of the market. So what is the current EV sales are there? So there is a study done by the McKinsey. It projects that there is a 1.5 million EV sales to be happen till 2020, which is being achieved, and nearly 46.08 million up to the 2025. This is a huge, because if you see that a 46.08 million EVs to be sold in the 2025, it is a huge, because it is jumped from the 1.5 million to 46.08 million. Okay. So because there is a EV, so it has certain battery, because there are different types of EVs such as plug-in hybrid. I am not going into depth, but the basic system is that it has certain battery. So for battery you need certain power. So how you get this power? You get power from this conventional grid. Conventional grid, you will get this power. How? This is the AC power which is coming, then you will convert this AC to DC, then give to the battery. So for that you need power. So if there is a 46.08 million cars are there, you need a huge amount of power. Huge amount of power to charge your batteries. What it means? It means that you need a power which is beyond your capability. What beyond the capability means? Beyond the capability of this conventional grid, because initially the IC engine vehicles are in a prominent stage. They don't need any power from this grid, so the grid is conventionally working very fine. Now there are certain kinds of load which is penetrating into our conventional grid, which is making the loading system, this is the power consumption, is at a very high level. Here I have shown one graph. If you see that this is a load curve. What do you mean by the load curve? It means the power versus time curve I have plotted. Here if you see, this is the 0 hour, this is the 6 hour, 12 hour, 18 hour and 24 hour. This is the duration, time duration, okay, of a particular day. If you see, this is the power consumption of a residential load which is shown during the summer, and the other it is shown in the winter. So what it means? It means that there is a certain capacity of your power plant, and during a certain time duration, your power capacity should be high to meet these consumers. So if EV is coming into market at a very huge level, so this peak which is coming here, this is the power consumption at a, suppose this is at a 9 p.m. or a 8 p.m. So this will go at a very high level. So what this means? This means that you need a more power generation sources. How you should do that? There is a certain methodology to do that. What methodology? First, you should increase the rating of your transformer. Why I'm saying that this is increase the rating of the transformer? Because what the conventional transformer, what is working into our system, that is working at a nearly at a 50 to 60% loading. It means that if certain transformer have time S MVA to play transfer, so it is working at a 50 to 60% of this capacity. So if you increase this with EV loads, if you say, so this 50 to 60% loading will increase. What do you mean? It means that it will go up to 60 to 70% loading. But what the permissible limit of the conventional transformer to provide the loading, that is 65% to 70%. And you also need certain margin. What do you mean by margin? To avoid the heating and all and the other losses, that is the 5 to 10% are there. So you need a certain improvement in your transformer. So our grid is a very huge, our conventional grid is very huge. So there are multiple transformer at a very different remote location for the consumers, end consumers. So you need to upgrade this transformer at a very high level. Suppose there are 16 transformer at a particular city, so you have to improve the 16 transformer. So it is a huge capital cost for your conventional grid, huge capital cost. So who is going to bear this? One thing is invest money and get this new transformer for providing this new type of loads. What is the second option? Second option, you need a decentralized generation systems such as the solar, wind and other kind of, that is the fuel cell based systems and other conventional sources for the generation of this for meeting this extra demanded load. So what do you mean? I have shown this curve, this flow chart. Here you have a small sources. So this is kind of a decentralized system is there, in which you should give this power to every consumers for generating the every consumer. So they will bear the power which is being consumed at their own level. If you have any doubt, you can ask right now. And moving to the first part of the question. If you have any doubt, please ask. You can type in the chat box also. Somebody is raising hand. Suleiman Samba. You can ask. You can unmute yourself and ask. Suleiman Samba, you can ask, no issue. Or you have any doubt, you can type in the chat box. Or session is going very fast. This also you can say that. Uh, uh, if you want me to be a little bit slow, and you can also type in the chat box. I want to jump to because this is a basic understanding. I have given the EV example that is very useful for understanding this smart grid concept. So I am moving to the first question. This is related to the 2012 Indian blackout, which was very used. And there are four, this is a five, statements are given. You have to identify the which statements is true and which is false. Solve it and give the answer to me, and you can write in the chat box or open your mic and tell me. My screen is not clear. Okay. Let me zoom it. You are using phone or any laptop system? 1 second, I am zooming it for you. And now it is visible. Akshita, now it is visible, or I will zoom it for you. Now fine. Solve this question and answer me in the chat box. Okay, Polas is saying that A, B, C is correct. I need one more answer to moving to the this solution part. Anybody else? Please be interactive. I have moved very fast. Why? Because you have not asked me. You have to stop me by asking question. Sir, why this EV is booming, and why you are telling that the low peak is increasing? You can ask me. That is a kind of healthy discussion will be happen. No. Any other answer after Polash? Anybody else? I need one more answer. So this will be very interactive, no, for understanding. Okay. Supradeep Ghosh Hajra, thank you for your answer. ABC. Let's go to the answer part. First question is that 2012 Indian blackout was the largest power outage. What answer is giving? A, B, C is the true, given by the true students. Okay. 2012 Indian blackout was the largest power outage in the history, affecting the entire country. This is the catch. Why? Because the southern grid, as you can see from this image, this is our India. This is our lovable India, and you can see that there are multiple states, and this is the brown region. Brown region is shown that this is the affected areas of this 2012 Indian blackout. It means that this is the wrong. Why? Because it is not affecting the entire country. It is affecting mostly to the northern, eastern, and somewhat central. Second, the blackout occurred due to a failure in the power transmission infrastructure, leading to a cascading effect. That's true. Why? Because true. Here you can see the blackout resulted from a failure in the power transmission line, leading to a cascading effect in the vast area. How this has happened? This is due to the one 400 kV line was there in between the Bina Gwalior Agra link. The high loading was there. High loading. What do you mean by the high loading? I have told you this high loading means, because your transformer have certain loading capacity, no? If you are increasing beyond this 70% to 80% level, it will overload it. And for the if the current is greater than this limit, it will trip. And this trip happened to a cascaded manner, which affect the many transmission line. So that is resulted due to a cascading effect. It means that it is true. Moving to the C part, there are several states in the northern India were primarily affected by the blackout, while southern India remained largely unaffected. That is true, no, my friend. Because why? Because the southern grid was remain unsynchronized with the other grid, because it is connected with the other grids are connected with the southern grid. How? With the HVDC link. And the blackout was occurred by the cyber attack, not cyber attack. The restoration of the power after the blackout took several days. Why? It is true. Disruption across the various sectors. That is true. Why? Because the blackout, there was a, if you are from 2012 or 13 previous born year, you can say that there was a scheme was there. It's not a scheme, but was a kind of thing was there propagating, that is Diya Jalao concept. And people were saying that the 2 to 3 days electricity will not come. That Diya Jalao Abhiyan was there to fulfill this need of this blackout. And so restoration will take for several days to come into existence, and this is not due to any cyber attack. I will come to this cyber attack. This Mumbai, recently the Mumbai blackout existed. Blackout, that is due to the cyber attack. That is due to the malware attack, cyber attack. And this blackout was not due to the cyber attack. So what do you mean that? There is a certain kind of system for there which is very prone to the this cyber attacks and other kind of things. What caused the cascading? I mean, okay. Let me take one more slide to answer you. Give me 1 minute. Oh. What do you mean by the cascading effect? Cascading effect means, if suppose this is a one substation is there, and this got tripped with a other substations which are connected with it. Suppose this is connected and other substations are connected and other substations are connected. Okay. And this substation is connected to some other substation. Why? Because our grid is interconnected. So suppose there is a transformer and you increase the loading beyond its limit. So this switch got tripped, and this substation, that is substation at this level, got disconnected with this substation. At that point of time, how the loading was still there, so this substation has to supply that loading. So this substation got also at a very high level, so this also got tripped. So that loading have to be supplied at a certain substation, then this substation needs bear this power. So that created a cascading effect to a cascading effect of disconnection between the various substations. So that's caused the major blackout into 2012. That is due to the cascading effect, because our grid is very interconnected. Very interconnected. Okay, it is clear? Okay, is it clear? Type yes or no so that I can answer your queries. You can unmute yourself here. You can ask me. This is a healthy discussion. Okay, fine. Let's go to the next question. This is related to certain standard, that is a memory based problem. I have told you why standards are important. Standards are important for the connections that for the penetration of various kinds of load into your smart grid or grid. So you can guess it. If you know this 1547 or P2030 IEEE standard, I hope that Swastik have cleared you why what kind of this standards are there. IEEE, ISC, ISO. There are multiple standards are there. Anybody? My screen is blur. One second. Is it still blur? Shibna, is it still blurred? My screen? Oh, one second. Now? I mean that I'm using this OBS software for the recording purpose. Okay, so in that you cannot expand this screen. This is one of this query. You can zoom it and answer the question. Okay, because we need to have a healthy discussion. So this is technical issues you have to resolve from your side. I suggest you to from the next time you should use your system for this, or I will use any other software for that. Now currently you should go on with this question and give me the answer. Akshita, you can zoom your screen. You can zoom if the screen is not visible, because the other students are giving answers. No, Polas is giving answer. Any other answer after Polas? Okay, let's go to the answer part. Here you can see first thing, why you need a standard, because the standards are needed for the smartly protection of your equipment and other equipment which is being connected into the system, It means that you need the certain standards for the smoothly protection of your equipment, and your equipment should not harm the other equipment also which is connected in your grid. For that purpose you need certain standard. Standard in what sense? In terms of power quality. How you define the power quality? One criteria is total harmonic distortion, and IEEE says that it should be less than the 5%. So coming to your answer, this is the C, which is a correct answer, which is given by Polas. Very good. IEEE 1547.3 says that monitoring information exchange and control of the distributed resources interconnected with the electrical power systems. What do you mean by distributed resources? Distributed resources means this is a smart grid kind of system. It means that it have a decentralized system So you need to control, monitor and exchange the information between that system and your system. So that you can properly communicate and transfer your data, transfer your information, so that the other system remains unaffected if there is a kind of fault scenario is there. And the second is the 1547.4, that is the design, operation, integration of distributed resources island system with electrical power system. What do you mean by the island system? Island system means the disconnected part with the electrical grid. And the IEEE P2030.1 guides for the electrical sourced transportation infrastructure. And the P2030.2 guide for the interoperability of the energy storage integrated with the electrical power infrastructure. These are the certain standards for the connection of your decentralized system into your main grid and with the smart grid. I have one question to you, with you all. How you do this information exchange? Information exchange. If anybody,
Smart metering.
yeah, exactly. The smart metering kind of system is there. By that you can communicate with your household system, and
IoT.
IoT based devices such as sensors, SCADA kind of system are there for the supervisory control, and other PLCs will be there for a higher industrial level. So these are kind of communication has been happening between a certain type of systems. So for that you need certain standard to communicate with the different equipment, different parts of the substations. So that is the important point of your information exchange. Coming to the next part of the smart protection system. This is the four these points, the statements are given, and this you have to tell me that what are the challenges, whether A, B, C, D all are the challenges to the smart protection system, or A is the challenge to the smart protection system, or C or D. I will explain in the further after you are giving answer. Please try this question. Okay, Akshita, let me try zoom it again.
B.
Okay, 1 second. Akshita, now screen is visible. Akshita.
Yes, sir.
Okay, fine. You can see. I will zoom it for you. Okay, no issue. Okay. Deepa Lakshmi is giving B. Any other answer? Any other answer, please? Any other? Oh, B. All are giving the B answers. Have you read the module? Oh, coming to the chalo answer पे आते हैं. Let's come to the answer part. What are the challenges? Is R. I have written specifically that is the is R. All answers are correct. How I am saying that? Let's jump. First one is the interoperability between the cryptographic system. If you see that this is cryptography. Cryptography means there are certain communication layers, communication and information exchange layer, and cryptographic system is a one of the layer in the communication system. So if you have to communicate, suppose there is a system and you have to communicate with the B, so you have to penetrate through this cryptographic layer and reach to this B for the sharing of your information exchange. So if A has certain layer of protection system and B has one layer of certain protection system, so if there are two different kinds of protection system which cannot be operated in a fashion that is they can communicate by themselves, so there is a gap will occur in the communication between both the system, that is the A and the B. So you need a certain mechanism which can transfer, which have a certain standards or certain specifications unanimously. Why? Because you have to transfer this exchange of information between the both system. If both system are capable and accepting and delivering the messages, exchange the information, so that is the important part of that smart protection system. Suppose there is a failure at A point, so you have to inform to the B that A has a certain failure, and if there is no interoperability, then must be a problem in the smart protection system. B, coming to the B part, the conflict between the privacy preservation and the information accessibility. Suppose there are multiple systems. Suppose there is A system, B system, and power generating system, D system and E system, and they are giving power to a certain load. Suppose this is L. A is giving power to the L, B is giving power to the L, C is also giving, D is also giving, E is also giving. Okay, so is at that particular point of time, suppose E injected with this power injection to the load certain malware. So if this system, all systems are interconnected, this malware can penetrate or can propagate to the other systems also by de-encrypting this information systems, de-encrypting. So the privacy preservation, the conflict between the privacy preservation and the information accessibility, because E have to send information to the L and L have to information exchange with the E. But what happened? It send some malware to the L, E sending some malware to L, but L also have to communicate with D. So malware that penetrated into the D system. So the privacy preservation is a major point of challenge in this smart protection system. Coming to the C part, the impact of the increased system complexity and expanded communication path. Why I am saying this? Because there are certain communication mechanisms. Suppose there is a Zigbee is there, your Wi-Fi is there. These are the low range devices. CAN communication is there. So you have a very large number of components are there into the grid. So you have to communicate to the overall system. So this expand the communication path. Suppose this system which I have taken, this L system communicating with A, B, C, D, E, and also this A is also communicating with A, or E is communicating with D. This is interoperability. There is a expanded communication paths will be there. And coming to the D part, the impact of increasing energy consumption and the asset utilization. This is the most important part. Why I'm saying the most important part? That is energy consumption. Why? Because there is a huge amount of system you are installing. You are installing PMUs, you are installing a SCADA system, you are installing this PLC based communication, you are battery backups. So that also utilizes certain amount of energy from this grid itself. So the energy consumption, you are penetrating EV also. So that is the huge amount of energy consumption, and you are also making the energy efficient system. So that is the asset utilization is very important, and it will impact, and the increase in the energy consumption also. Is it clear? Is it clear to everybody? Supradev, correct, ABCD. You have any doubt? Kumari Madhu, you can ask, open your mic. Kumari Madhu, you can open your mic and ask. You can ask in chat box also, no issue. I think there is a communication error between ourselves and Kumari Madhu. So that is also a problem, because we are also an interconnected system right now. So if there is a communication error between you and me, that is also going to be a huge problem. So this is a question, and I have zoomed it, and you have this A side, left side, you have a energy based technology type, and the right side you have a output type. What do you mean by the output type? It means the what kind of energy generation can happen from this energy based technology type. You have to give answer that which are the options are correct. Suppose there are all 6 are matched correctly with this right side output type, you should say 6. If the 5 are correct, you should say 5 or 2 or 4. I will explain that how why I am saying that. Please solve this. Four. 4 means fourth option or 4? That is the same. D option or 4. Any other answer? 4. 4. Sandeep is saying 4. Any other answer? Any other answer? It's kind of competition also, no? Ki how much information can you absorb right now? You are young and you can absorb as much information as you can. You can expand your mind also. First part, Polas is saying first. Let me see that which is the correct answer. Aruna is saying A. Any other answer? Any other answer? Any other answer? Guys. Akshita is saying 4. Let's jump to the answer. Let's jump to the answer. Yeah. Guys, see. First one is the correct answer. All are correct. Why I am saying that? If you see, this is a reciprocating engines. This develop the AC power. This develop the AC power. This is normal conventional engines which you see in your vehicle also, and other thing also that generate. I will give example here. First one is this is there are certain kinds of electric vehicles are there in the market, no? First one is the battery electric vehicle, which you fully utilize this battery. Second is the plug-in hybrid electric vehicle. Third is the hybrid electric vehicle. No, so there is a hybrid electric vehicle concept is such that this IC engine is there. IC engine is there, which give power to the vehicle also, and also the battery also. It means that this battery is getting charged, having this DC power supply, getting charged with this IC vehicles also, and also this vehicle is also getting power from this IC engine. This is kind of hybrid system. Let me come to the part. Sorry for the interruption, guys. So this IC engine giving power to the battery. How this is giving power? This is generating AC power and AC to DC converter by using this giving power to the DC supply. This means that this IC engine vehicle will generate this AC power output type. Coming to the micro turbine. Micro turbine is a basic concept, but it is you can expand to this hydro turbines as well. So it will generate the AC power. It means that the both are correct. Coming to the fuel cell, it's a kind of you can say this is a DC power. It can absorb DC power, and the photovoltaic system, which is you are very much aware of that you need one DC to DC converter for boosting your voltage and one MPPT for setting for the higher power maximum power generation. So this also give the DC power. Solar thermal, you if you can see some people will think that it is also solar and this will generate DC. That is not the case. It generate AC. Its output type is AC. How I am saying that? There are certain, suppose this is a kind of generating solar thermal systems are there, and this is a one chamber is there. So if sunlight falls on it, it will go to this tower. This tower is such that it will generate this AC power, and which is directly fed to this grid, directly fed to the grid. Not But in the photovoltaic system, you don't have this kind of system that this generated power DC is directly fed to this AC grid. You need a base DC to DC converter and then DC to AC converter inverters for that. This solar thermal concept is completely different from the photovoltaic system. And next one is the ocean energy, which is very prominent nowadays. IIT Madras is doing very much research on this. They have one branch also. You can try that. Ocean engineering on the in the name of ocean engineering. That also generate this AC power. So the correct option is 6. Okay. So coming to the next question. Let me explain this question that this is the microgrid. Certain statements are given for the microgrid. I will explain what is the microgrid. This is the microgrid. This is the microgrid based. These options are there. So you have to say that which are the options are statements are correct. A, B, C, D, E. Which of the statements are correct with respect to this microgrid? With respect to microgrid, which are all are the statements are true?
Hello, sir. Sorry to disturb, sir. Hello.
Yeah.
Sir, actually this screen is not visible fully.
Okay, let me.
It is not visible full.
Yeah, I have made that why? Because some people have issue with this lower screen. So this is the question only. This is the E statement. A, B, C, D, E statements are given. This is the only question. A, B, C, D, E.
Okay.
If you are seeing this A, B, C, D, E options,
Yes,
okay,
yes,
that is the only question. That is the image I have put it for your explanation. Okay.
Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank you very much.
Okay. You can try that. Try the question. Okay. Deep Lakshmi is saying ACE. Any other answers? Sandeep is saying AE. It means that either C is correct or C is not correct with respect to Deep Lakshmi and Sandeep Vashnik. So let's see. Any other answer? Any other? ACE. Other as giving. It means that microgrid concept is clear to you, but I will explain for them what is the microgrid and the systems. ACE. Any other answer? Any other answer? Rishu, Imtiaz, Akshita. Any other answer? AC, Ritika is saying AC. Okay, fine. Okay, let's come to the answer part. Let's discuss. Okay. The first question is like that. The microgrid are decentralized energy systems that can operate independently or in conjunction with the main power grid. Is it true? Yes. Why I am saying that? Because the microgrids are decentralized energy systems that can operate independently or in conjunction with the main power grid. Here I have given an image right side, which is not fully visible, but you can see this is a part which is inside of the ocean. There is a in the center or any other part in the deep ocean, in a outer part of this ocean, there is a microgrid setup is there. So it can be connected to a central grid, but it can operate independently also by generating this power from this wind, this solar, and transfer that power with this transmission line to the remotely located consumers. Okay, so it can independently operate, and it is a decentralized energy system. Coming to the B option, microgrid typically relies only on the renewable energy sources such as solar, wind for their power generation. Guys, this is not correct. Why I am saying that? let me take one slide for this answering this question. This is a very important. Why I'm saying this? Suppose there is a PV system, PV solar plant is there, and a battery backup is there. Why battery backup? Because after generation it will generate the VDC supply, then there is a certain mechanism of DC to DC converter, boost converter, then it will transfer to a DC link capacitor or any central load, and this have to maintain, and this is connected to the grid. This is connected to the grid with the AC to DC to AC converter inverter. This is the inverter part, and it will be connected to your grid. Now, in between you have household loads also. So this is the DC part, and this is the DC converter part, and this battery is also will be connected with a buck boost converter, DC to DC buck boost converter, and it will be connected to this DC link voltage either here. Why I'm saying that? Because PV generation is not continuous. It have a certain curve, irradiance curve. It have morning, it have generate very much power, then in afternoon it will generate a certain amount of power. After that it will also it will generate the less amount of power, then it will fall down. So you need a certain mechanism to stabilize this DC voltage link. Because why? This is because you need a certain supply to maintain this DC link and to this grid also. So for that you need that backup. Okay, is it clear to everybody? Is it?
Yes, sir.
Okay, is
Fine,
it
sir.
okay? Fine. Let me one second. The system got hanged. 1 minute. Don't go anywhere. I'm taking care of this. Does my screen is visible?
Yes, sir.
My screen got hanged. Yeah. 1 second.
Same thing, sir.
Huh?
Yes, sir. It is visible.
Yes, sir. Visible.
Yeah, it is visible, but my system got hanged. I have to restart my system. If you don't have any problem, I will be back in 2 minutes if you allow me.
Okay, sir. Okay.
No issue. Please join and see this. I will come back in the 2 minutes. Don't go anywhere, no? Okay? Does my screen is visible now?
Yes, sir.
This
Yes, sir.
this PowerPoint, this presentation is visible. Okay, fine then.
Yes, sir. Visible.
Okay, let's start the session again. Oh, sorry for the interruption. let's come to this microgrid kind of setup which we are studying that. And I have told you that you will need this all the, not all, this A part is correct and B part is correct, and for the C part this I have to explain you all. Micro typically only do the B is false. Why? This is not typically depend upon the solar and wind for their power generations. And the primary purpose, C option, the primary purpose of a microgrid is to provide a reliable and stable power supply during the grid outage. It is correct. Why? Because a microgrid is basically a decentralized power generation system for a backup kind of system. You can generate and supply for the normal your household, for your personal use also, but it is also a backup for the under the condition of the grid outage also. This is a microgrid. And for the D option, microgrid are mainly used in the urban area and have limited applicability in the rural or remote locations. This is solely false. Solely false. Why I am saying this? Because in our lab in which I work on, they have a certain kind of project which is occurring in the Chhattisgarh and Jharkhand remote locations, where this solar penetration is very high, but the normal grid cannot reach due to the mountainous region or other kind of climatic and geographical locations. So only they install this solar power plant to generate their electricity for their consumption. And E part, advanced control system are essential for optimizing the performance of the microgrid and balancing the supply and demand of the electricity. That is correct. Why I am saying that? Let's take the example. What I have shown you. I have shown you that you have a PV system and you have a battery system also, and these all are connected to this inverter for DC to AC conversion with a DC link, then to the grid and your household supply. So you need a control mechanism which can transfer this power battery from the battery to this inverter to maintain the voltage to this DC link. Because why I am saying that? Because for the conversion of 230 volt RMS, you need a DC link voltage up to this 500 to 700 volt for the generation of this 230 volt from a inverter. So because the PV system is unreliable. Why I am saying this is reliable, but this is due to the irradiance problem, morning peak and evening low. This is the intermittent and a non-continuous supply of generation. So but you have to maintain this 500 to 700 volt. How this voltage is maintained? From the battery by using this DC to DC converter, that is the buck boost converter. And if there is a surplus supply by this PV, then battery should charge, and there is a no generation from the PV, so then this battery take the power from the grid also to charge, because it have to maintain a certain voltage level and certain SOC level. Okay, is it clear to everyone? Type yes if it is. Okay guys, it means that I am going on a right path. Thank you everyone. Thank you so much. Let's move to the next question. This is the solution also, and I will share the slides with you all. Coming to the next question. Next question is context to this smart information systems of the smart grid, and you have to determine find out that which is true and which is false. There can be multiple truths and multiple false. You have to determine which is true and which is false. Does my screen is visible? If you are not visible, I will zoom it type in class in this chat box or anything. Okay. Okay. Any answers? A, B, E, A, B, E. One answer is A, B, E. A, B, C, D, E. This is not the tricky question that all are correct always. So you have to think. You have to think. A, B, D. A, B, D. Multiple different answers are coming, guys. It means that there is a lag between the concept and their solutions. Maybe somebody is correct. All are correct. Maybe possibility. Any other answers? Any other answer before jumping to the answer part? Any other answer, guys? Okay, fine. Let's go to the solution part. First one, let's read it. First, what A option is saying that smart information system in the smart grid uses advanced communication technology to enable real-time monitoring and control of the electrical grid. That is right. That is right. I will explain this PMU concept in the further slide, how they are managing this real-time monitoring and information exchange. That is right. Coming to the second part, this system plays a crucial role in enhancing the efficiency and reliability of energy distribution by providing insights into grid performance. Insight into the grid performance. That is true. That is true. Why I am saying this is true? Because you have a certain monitoring screen is also there at a certain locations. That is a SCADA supervisory control is also there, where you can see that which power plant have a normal condition and which power plant having in a faulted condition. At a remote location also through this PMUs and GPS based system. I will explain in further slides. Coming to the C part, smart information systems are primarily focused on consumer engagement and have minimal impact on the operational aspect of the smart grid. That is false. Why? It have a consumer engagement. That is correct. Why? Because the two-way communication is possible in the smart grid. That is fine with the system. 1 second. Okay. And minimal impact on the operational aspect of the smart grid. This is false. Minimal impact is not there, but they have a high amount of operational aspect of the smart grid. They can manage the grid remotely. They can observe the frequency remotely while using the wide area management system. So coming to the D part, the integration of the smart information system allows the seamless integration of the renewable energy sources into the smart grid infrastructure. That is correct. Because you have a large, huge amount of decentralized system. Coming to the E part, cyber security is not a significant concern. That is false. Why? Because you can see that this Mumbai, Maharashtra blackout, recent Maharashtra blackout, that is due to this cyber attack. So you need a cyber physical system, cyber resilience system for this smart grid. Okay, fine, guys. So coming to the next question. This question is such that there are multiple functions and features. A, B, C, D, E is such that this is the function, and in the down portion there is a blank box and written 1, 2, 3, 4, 5, and you have to tell that which function matches with the correct feature, which function matches with the correct feature of the system. You have to say that. Suppose A is matching with 1, you can write this the A1. Okay, fine. Okay, Sandeep, your answer is right. Good. Okay, इम्तियाज is asking that do we use the robotics? हिंदी में समझा दिए थोड़ा सा. Okay, engineer Raman. Okay, I will explain the Hindi and English. Okay, because the people are from the everywhere. No. Do we use the robotic monitoring system with a smart grid? You can say that. Why this is robotic? You have to see that what is the meaning of robotic. Then you have to see that robotic monitoring system. If the smart grids have a certain component which is robotic and it is related to a monitoring system, then you can see that this is a robotic monitoring system, but not a robotic monitoring system as per my knowledge currently is there, because there is a human intervention is there. Any answer? Any answer, guys? This is the seventh problem. Okay, answers are coming. Deep Lakshmi is giving 3B4 C1 D5 E2. That is actually, this question is very easy. If you understand this statements, you can easily answer the question easily, because in the question itself there is answer. Any other person? Any other person? Sibna. Deep Lakshmi answer is matching with the Sibna, so I think that is correct. Any other answer? E2, Rishu is saying, so means E2 is also correct. That is matched with the other answers. Any other people? If you have any doubt, you can open your mic and ask me, so that this could be an interactive session. And this is going on, but I think more interactive session. Okay, let's go to the answer part. Okay, let's read it. First is the A. A part is real-time monitoring of the electrical equipment. A part. Let's. Anybody raising answer? Okay, let's read it first, second, third, fourth, fifth, and what answer I have got? The A3, B4, and other is C1, and other is D5 and E2. D5 and E2. Nearly all have given this same answer. Hopefully this will be right. Let's read it. Coming to the A part, the real-time monitoring of the electrical parameters. Answer given is 3. Monitors electrical parameter continuously, allowing for the immediate responses to changes or disturbances. That is actually correct. Why? Because you need the real-time monitoring of the electrical parameters for the immediate response to a changes or a disturbance. Suppose there is a fault at a particular location, then at that particular time you have to respond immediately, and you have to disconnect. You have to disconnect the system to avoid the 2012 blackout type of condition that is due to the cascading effect. Coming to the B part, that is the fault detection and identification. Answer given is 4. Identifies and locates faults. That is correct. Identifies and locates fault in the grid, aiding in rapid response and minimizing the downtime, because you have immediate response. C part, predictive maintenance capability. Predictive means, suppose you are a present day. At present, I am at a 28th of Jan, and I need a predictive mechanism for a 29th Jan. Power consumption, load curve. So that is kind of system is known as predictive kind of system. So predictive maintenance capabilities, C answer is given 1, provide insight into the health and performance of the grid components, allowing for the proactive maintenance. That is correct. Very correct. Coming to the D part, integration with the advanced analytics for the grid optimization. D answer is given a 5th. That is correct, also correct. Why? Because you need a smart sensors for the data with advanced analytics and contribution to the optimization of the grid operations. You need a real-time data exchange between the systems, and you also need the communication with the other devices in the smart grid. That is related to the 2 part. enabling communication between the sensors, other devices, facilitating coordinated action between this module. Okay, it means that all your answers are correct, guys. Okay, that's great. Coming to the next question. This is related to the PMUs. I will explain the what is the PMUs. If you have a basic understanding, you can go through it, this question, and I will explain it what is the PMU and what is the working of it. Guys, please try. Any answers? This question is important, actually related to this PMUs, real-time monitoring and real-time data exchange. AC, C is given. See that here the question is R. It means that multiple answers can be correct. Multiple answers can be correct. You can read the all answers, all questions. A or C, AC, A or C. Okay, guys are giving answers A or C, A or C. Any other answer? Any other answer? Guys, please participate. That will be a very interactive session, and I will clear your any other doubt related to examinations, any other type of things. Okay, at the end, A and C. Okay, guys. Let's jump to the answer part. So, this is actually a basic PMU diagram. I will explain what is PMU, then we will jump to the answer part. This is a basic working diagram of this PMUs, phasor measurement. PMU's full form is phasor measurement units. Okay. So there is a power system network. Power system network, what I mean, what I have explained in the first slide. That is from the generation to the distribution side. This is the power system network. And the output from CTs and CVTs. CTs is the current transformers, and CVT is the capacitor voltage transformer, CVTs. Okay, so there is a isolation transformer and surge protection. How I am saying that? Because in your grid you have a multiple voltage level. Suppose that is a 22 kV voltage level, 230 volt level, 132 kV level. These kind of voltage levels are there in your power system network. But your measurement system, what if you use this normal voltmeter or ammeter for the measurement of this kind of voltage, then that will not be a feasible option. For that, what do you need? You need to step down this voltage. Step down this voltage to this voltmeter level, or step down to a high current level to a low current level using CTs, current transformers. So that is done to the CTs and CVTs, that is CTs and PTs, instrument transformers. Then you have a isolation transformer and a surge protection circuit. Surge protection, you need the protection device everywhere in the network. But why? Because you have to protect yourself also, you have to protect the healthy part of the system also. Then you have a sample and hold circuit. Sample and hold circuit, what do you mean by this? Because you need data, you are observing the continuous data from the voltmeter, ammeter, CTs, PTs, or any measurement devices by the voltage or getting the current and voltage data. For that data is being transferred in the sample wise to using DFTs, discrete Fourier transform based system, or any other transformation systems by the use of this sample and hold circuit. So that analog signal which is coming into system, that is through this system, sample and hold and ADC system, is converted into digital form. Then digital form this data of this voltage, current, and go to a microprocessor which is connected to a GPS receiver. What do you mean by GPS receiver? I mean, there is Earth have a 6 satellite which is connected in the geostationary positions at a 60-degree angles, that is receiving data from every geographical location of the world. So that is the GPS, and it is connected to this microprocessor. Is it connected to this microprocessor? And what is the use of this oscillator? Suppose there is a mismatch between the information between the GPS receiver and your microprocessor, then this oscillator will take care of that situation. This oscillator will generate that clock pulse related for this microprocessor for generating a accurate result of your voltage and current phasors. And this modem is to transfer the data or receive the data from a different units. What do you mean by this? I will explain further here. Let me explain. I will explain further to your how this is actually happening into your system. Let me see. Okay. So you have a PMU that is a phasor measurement unit. Phasor measurement unit that can receive the data from a different position using GPS based data, and also send the data using this modem. Okay. So there are certain grids. Suppose there are certain substations are there, several power networks are there. Suppose this is the one power network is there at this position, and one is at this location, and one is 3 location. So this grid, this interconnected systems are there in between the all system. So this one system will generate a certain voltage and current data, and this 2 system is also generate this voltage and current data, and third also voltage and generate. That all are connected to this GPS system. This all are connected. This 1, 2, 3 systems all are connected with this data. So what is the important point of this? First one is the real-time monitoring of this system. Real-time monitoring, and suppose second one also the control also. Why? Because you need the remote located points. You need a data from a remotely located point, so that the continuously monitored what the actually happening in your system. Okay. So how this PMU measured these phasors? If you see the right side diagram, there is a sinusoidal signal is there, and there is a dotted line. Dotted line is such that it is a reference. And if you see, there is a theta angle is given between your reference and what is coming into. Does my screen is visible to you all? My screen is visible, guys? Okay.
Yes, sir.
Okay, fine. Sorry for the interruption, guys. I will take care of from the next time. Okay. Let's move to the next question, and this is related to a basic problem related to the power range of a commercial loads. What is the correct answer? Guys, please try. D option somebody is giving. Are you sure? I have written is or, if you can see. Are you sure? Commercial load. Okay, do catch me. D is correct. D is correct. One more answer is coming. Okay, coming to the answer. This both answer B and C is correct. The commercial load lies in between this 20 to 200 kilowatt range. This commercial load, and industrial is 200 greater than, and this less than or 20 is the household household consumption. Why I am saying this? There are three different kinds of loads. If you see, this is commercial, industrial and household. If by your intuition also, if you see, the industry will require a higher amount of power than this commercial. What kind of commercial? This kind of suppose there are this TCS companies there. It's a kind of a commercial system. Amazon based Amazon companies there, they have a certain headquarters. Then kind of commercial. Industrial, certain kind of manufacturing base is there. So it requires a higher amount of power, that is a 200, greater than the 200 kilowatt. Okay, is it okay? Okay, let's go to the next question, that is related to this IC and IEEE standard. I think this is related to mostly memory based problem, memory based. So I will come to it at a last. Okay, let's come to the more technical topics. This, guys, please try this question. This is a very important question, very important question related to signal processing, aliasing concept in the signal processing. I will explain what is this aliasing in this signal processing. Please try this. Please try this. If you have a background. Question 9. Somebody asking, please explain the question 9. Okay, I am explaining question 9 again. That I have said that there are three kinds of load consumers are there. First one is the commercial, second is industrial, third one is the household. So commercial is such that they are not any manufacturing basis companies. They will manufacture but in a very small level. They can manufacture plant. Like TCS is there, Amazon is there. But industrial level, that is the Tata Power. Generating sources, that is Tata Motors, that is industrial kind of loads. And third is the household. So most requirement of the power is at a which level? That at a industrial level. Okay, and the most least amount of power consumption is the household. So I hope I have explained your doubt. Please solve this 11th question. Ritika. Okay, welcome Ritika. Please solve this question. A option, somebody is saying A option is correct. You can see this R is given. Multiple answers can be true, multiple answers can be false. A may be correct, A may be false, and multiple answers can be there. Any other answer, guys? Rohan, Mayank, Umar, Rishu, any other answer? AC, AC, somebody giving AC. Any other answer? Any other answer? 1, 4, AC. Okay guys, let's come to the solution part. First I will explain the what is the aliasing and how these options are being correct or incorrect based on this concept. First let's explain this aliasing part. There are three kinds of sampling states can be there. You have seen that in the PMUs. There are three kinds of this. Three kinds of systems can be there, sampling states can be there, that is the oversampling, perfect sampling or undersampling. Oversampling, what do you mean by oversampling? It means that the frequency, that is the FM is your message frequency. Message frequency which is coming from the CT data, PT data, CVT data, okay? And FS is the sampling rate at which you should sample this data which is coming from these sources. So there can be two conditions, oversampling, perfect sampling, and undersampling. So there is a state, that is if there is a FS is greater than 2 FM condition is there, then it is said that it is a oversampling and it is a perfect condition. Because if you see that this is a data which is being in a frequency domain, but you get the data in the time domain, which is converted using this Fourier transform or DFT, discrete Fourier transform, y omega. So this is a perfectly captured signal. And if you go to the perfect sampling, it is related to the boundary, because if a certain disturbance can happen, then this message signal, this is which is at the right side and which is I am drawing in the left side, can intermix. So if there is a FS is 2 FM condition is there, that is a perfect sampling condition. And if FS is less than 2 FM condition, it means that there is a aliasing. Aliasing means this is data loss. Why? This is the distortion, because if you cannot capture this signal, you can capture the signal, but you cannot define that what kind of information is this, because it is got mixed, it got aliased at a particular time. So this is avoidable situation, that is the FS is less than 2 FM. So coming to the answers part, question part. So first option is that aliasing occur when the sampling rate of signal is greater than twice the highest frequency of the signal. Okay, it means that is correct. This is known as the Nyquist-Shannon sampling theorem. That is actually correct, because I need this oversampled signal. Okay, it can be avoided, but here one can option be there, Fs is equal to 2 FM. That is also good condition, but oversampling is only preferred in the practical situations. Okay, and in second, anti-aliasing filters are used to prevent aliasing by attenuating frequencies above Nyquist limit before sampling. That is actually correct, because Nyquist limit is what? Nyquist limit is your Fs. Fs is equal to 2 FM is your Nyquist limit. But how you are doing this preventing aliasing? By making it greater than 2 FM, oversampling it. Okay. Third option is that aliasing can lead to a misinterpretation of the highest frequency component as lower frequency, causing distortion in the reconstructed signal. That is correct. How I am saying that? Suppose, see in the this cursor, how I am drawing that. Suppose this is the frequency component F1, and this is another signal which have a highest frequency component as F2, and this is suppose this is a central frequency and this is F2. So what frequency will be this? This will be F2 minus Fc. So this frequency and F1 frequency got intermixed, because this F2 minus Fc is a part of the second signal, but is coming in the part of the first signal. So the higher frequency component can intermix with the lower order frequency, which can cause a distortion to your system and cause a noise or any other data losses. So this is correct. Misinterpretation can happen. You can consider F2 minus Fc is a part of first signal, but is not a correct. It is a part of second signal. Coming to the fourth option, that is increasing the sampling rate of signal always eliminate the possibility of the aliasing, ensuring accurate presentation of the original signal. That is wrong. Why I am saying that? Because if you are sampling certain things, you have to consider the masses. You have to see the masses frequency first, and you have to make the sampling frequency such that the twice greater than the twice of the masses highest masses frequency. You can increase from FM to 1.5 FM, but that is not avoid the condition of this aliasing. So it means that increasing the sampling rate greater than the twice of the masses frequency can avoid this aliasing problem, but not just increasing this sampling rate. Is it clear to everyone? Type yes, or I will explain further if you have any doubt. Okay, fine. So if you have understand this, then try this problem which is on the screen. It is a very easy problem, but you can try again. Try this problem. It is very easy depending upon the what I have explained. Write in the chat box C option. Somebody is saying C option. That is the easy problem I guess. Easy problem. Sandeep is also saying B. Sandeep is saying B. And the two options are C. Okay, let's go to the jump to the answer part. Let's see that which is correct. What I have explained that the sampling frequency should be greater than or equal to twice of the masses signal frequency to avoid aliasing. But what the practically says, it should be Fs should be greater than 2 times of FM signal. Okay. So what the question is saying, consider a signal with a highest frequency component of 1000 Hz. According to the Nyquist sampling theorem, what is the minimum required sampling rate to avoid aliasing? What is the minimum? Minimum means at a threshold, at a boundary. It means that it should be Fs is equal to 2 times of Fm. 2 times of Fm. What is the answer? Its answer will be C. And somebody have given the B answer. B also answer. This Sandeep have given. Sandeep, my friend, this Fs should be greater than or equal to 2 FM for capturing this entire signal without aliasing. So B option cannot be correct. It is less than the 2000. That is the twice of this masses frequency. And if this minimum is not written, then just ask that what is the sampling rate required to avoid aliasing. It means that it should be greater than 2000. So the correct answer will be 2500 in that case, if the minimum answer is not given, minimum in the question is not given. Okay, is it okay to everyone? Let me go to the next part. Okay, try this question. This is question related to the memory. Memory part is also crucial because you need the, if you are exchanging information, you are collecting data, you need memory to store it. Two kind of memory is there, volatile, non-volatile, and try to solve this question. I will explain further. I have given the comparison also. Please solve this. Please solve this question. One, two, three correct. Deepa Lakshmi is saying 1, 2, 3, 1, 2, 3, 1, 2 is correct answer. Somebody, Arshia is giving, Sidna is giving 1, 2 answer. Seta Bandra is giving 1, 2. Okay. Okay, fine. Let's come to the answer part. Let's come to. This is the answer. Actually, this I have given this comparison part in the right side of this screen. This is not correctly visible if your screen is not in a zoomed condition. So I will explain this. Volatile memory is certain that the data is lost when it's switched off. It means that when the power is off kind of condition, then data will be lost in kind of volatile memory. But in the non-volatile kind of memory, the data will not lost when it is switched off. So what you need in the kind of smart grid kind of system, because you need the data backup also, no, during the power outage condition. So non-volatile memory is perfectly for the smart grid conditions, and data temporarily is stored in the volatile memory. And certain position you need also this data volatile memory also in the smart grid for a real, suppose you are monitoring in a real time and you need the data of 20, you have the data of 24 hours, you can erase it, and on the next day you again take this 24-hour data, you can erase this and again take the 24-hour data for the real monitoring. Okay, and it is also slower. The non-volatile memory is slower as compared to this volatile memory, and I have given this this comparison also. And the example of this volatile memory is the RAM, and the non-volatile memory is the ROM. So what are the correct answer? First one is correct, second one is correct, third one is also correct. Why? Because the volatile memory loses its stored data. Second, the random access memory RAM is example of the volatile memory, and third one is the volatile memory is generally faster as compared to this non-volatile memory. Okay, it is fine, guys. Go to this 14. This is also very important in terms of this management point of view. It is also, you have to see that which authority is important for which type of work in your present power system or present conventional power system or your smart grid. Which kind of authority? Please answer this question. You can consider A as 1, B as 2, as C as 3. Here I think the ABC comparison is given. Consider you said 1, this is 2 and this is 3. First B, second C, third A. First B, second C, third A. It means that no answer is coming correct. Third option is giving somebody, Sandeep, Kulash, Arshia. Any other answer, guys? Aruna, third answer. Okay, Shweta is also giving 3 answer. Ritika is 3. Geom is giving again 3 answer. Okay, let's jump to the answer part, guys. First, if you see this CA is the policy making body. So if you see this, let's again come to this CA, Central Energy Agency. CA is a advisory board. On the matters related to national electricity policy and formulation of short-term and perspective plans for the development of the power system. This is the advisory board and related to what? This policy related matters, this CEA. And CERC and SCRC. CERC means Central Electricity Regulatory Commission and SCRC is State Electricity Regulatory Commission. It regulates the tariff, formulate policies regarding subsidy and promotion for the efficient environmental policy at a central and the state level. Okay, let give me one example related to EV itself, that is the FAME scheme. FAME scheme is launched by this central, but in the states also there is a EV policies related to central state also. So this central is managed by this CERC and state part is managed by SERC, State Electricity Regulation Commission. And coming to the C part, this CTU and STU, this central transmission unit and state transmission unit. This is a development of the efficient and coordinated and economical system for interstate and intrastate transmission line. From the U, you can consider that this is the utility for the T. T means transmission kind of thing. C for central and S for state. Okay. So coming to the answer part, this first one, advisory. Advisory means this CA. First one is the B, and second CRC. Second is A, efficient combination. This C part is A. मतलब third of A. Means no answer is correct. It means that first is B, second is regulatory tribe, that is the C, third is A. It means no option is correct. No option is correct. Okay, let's come, kind of trick question. Let's come to the last question. Last question of this session. Last question, I guess. Let's come to the last question. There's a 15. Please try this question. This is related to the share of this wind and solar generation in Indian grid respectively as per the 31st December 2023. I will inform you from where this data came and how you can read it. Any answer of this? A. Somebody is giving A part. Sandeep. Sandeep is giving A. Maybe this may be correct. Think like that the wind potential of India is greater or less than the solar potential of India. Which one is greater? Wind potential or solar potential? Ravikant is also giving A answer. Narendra is also giving A. Om is also giving, Om is giving B answer. Okay. Any other? Deepa Lakshmi, Mayank, Omar. Any other answer? Ritika. Any other answer? Okay, B answer, solar energy is more potential. It means, okay, that's correct. Solar energy is more potential in India. We are the leading. We are leading. We have also have a headquarter of this International Solar Alliance. Okay, A, somebody is giving. Okay, let's jump to the answer. Okay. First I have what said? The solar potential is greater than the wind potential in India. That is the correct. So which options are correct? D options and B options are. So in both, one option will be correct. So I have eliminated A because the solar, sorry, I have eliminated B and D. So I have A and C options left. C options are left. So now I am saying that this 100 gigawatt capacity, we have not achieved it. We don't have 100 gigawatt capacity of this solar. We have 73, nearly 73% gigawatt production as per this CA report. You can go to the CA website and type CA renewable energy share. You can find out this report. So the correct option is A, and this 100.20 gigawatt is a small hydro capacity currently, small hydro capacity. Okay. Okay. Is it understood by everyone? Type yes. Okay, Seta 100. Okay, so last few minutes is left. So if you want me to discuss anything related to any query related to your academics or anything, you can ask me. Any related exams related to GATE or research related activity, electric vehicles, and also please give some feedback in the chat box. I also need that. Sorry for the 2 times outage for the interruption, guys. Please type in the chat box that how was the session, and also please type the if you open your mic and ask if you have any doubt related to academics, competitive exams, or anything.
Thank you very much, sir. Sir, it was a great session, I think.
Thank
Always,
you.
sir.
Thank you, Imtiaz.
Thank you for a great session, sir.
Thank you, Imtiaz. Hopefully.
Thank you, sir.
Okay, thank you, Sundaram. Actually, I will make the more interactive session in the coming time, because the initial, this is the only the first assignment have been currently done by you all. So in the coming sessions, I will give the more briefing what is actually happening in the global scenario and the current Indian scenario. Okay, you have anything you can ask. Open your mic and ask.
Sir, I have a question regarding preventive maintenance and predictive maintenance.
Okay.
What is predictive maintenance? Because normally, mostly preventive maintenance is done to avoid any breakdown.
Okay.
Predictive maintenance is a new thing, so that was my doubt.
Okay. Actually, the predictive maintenance, suppose I have give one example, predictive maintenance. Okay. Let me take one slide for that. Here you have said that this is maintenance part. I have said this predictive and primitive or something. Predictive is kind of which you have to do by the predictive. It means that suppose you have any equipment and you are not getting output as per desired. It means that you would check it. You will check it. It means that you are doing the preventive maintenance of that system. What do you mean by the predictive? Predictive means you are predicting that your equipment will go in fail in coming 2 to 5 years. So you need this predictive maintenance of that system, predictive maintenance. Suppose I will give one example of the EV also. EV have a battery and the battery have certain health, and you discard this battery when the 70% of capacity is lost. No. So how you will know that this is the coming to the 70% level capacity? It have come to the level of 70% capacity. This is done through the predictive analysis, that from the last 5 to 6 years you will have this battery health drop down to 100, from 100 to 70%. This means that you are doing a predictive analysis that you will need this new kind of battery after its health reduced to the 70% capacity. That is kind of predictive analysis of your battery for the EV. Okay. Jim, I think I have answered your question. If you have any other doubt.
Yes, sir. Thank you, sir. Yes, sir.
Thank you very much. Okay. Any other doubt, guys? If you have any other doubt, otherwise I will end this. Shweta is asking if somehow we miss the live session, is there any way to take it from any platform? Yes, this will be shared by this NPTEL authorities because they have taken this video lecture recording. They demanded this video recording and in the YouTube channel. So they will share that YouTube link from where you can see this video again. Okay, Shweta.
Good evening, sir. My name is Sandeep.
Okay, one by one. Jayom, please.
So what about the exam? Like, what will be the pattern of questions? Will it be like multiple choice or? there will be subjective
it
questions
will be
also.
MCQ type, related, mostly related to your assignments, mostly.
Okay, sir. Okay. Thank you.
Sandeep?
Yes, sir, same questions.
Same. Has actually the this exam actually conducted by this NPTEL, and we have not given any information like that. But I have given one NPTEL examination, so I have that experience that same assignment type of questions come, the MCQ type.
एक्चुअली सर टुडे सेशन आई विल थोड़ा लेट हो गया था, मैं जब क्वेश्चन आंसर की सीरीज चल रही थी तभी ज्वाइन किया था मैंने.
ओके, कोई बात नहीं, ये अपलोड हो जाएगा यूट्यूब चैनल पे. ओके
यस सर.
ओके. इम्तियाज?
सर नेक्स्ट टाइम आई विल डू परफॉर्म बेटर.
नो इशू संदीप. एक्चुअली हम लोग भी तो इंसान ही है ना, तो हाँ, एक बार सही करेंगे, अगली बार गलत करेंगे, फिर सही करेंगे. ओके. इम्तियाज?
हाँ सर जी. सर एक रिक्वेस्ट थी सर, कैन आई आस्क सर?
हाँ, बिल्कुल बिल्कुल.
जी सर, एक्चुअली आई हैव रिसेंटली completed my BE electrical engineering sir.
Okay.
So now sir I am looking for RA, research assistant in this field. So is there any project going on recently or currently sir? Sorry
Can you repeat again?
sir, as I have been already graduated last year,
Okay.
23rd.
Okay.
So I am taking this course right now for the knowledge sir.
Okay.
Knowledge. So now sir I want to join I want to join the project sir in any lab. Do you have any project sir currently?
Actually, I am also a research scholar working under Grid Integration Laboratory, IIT Bombay. So we have one website called this Grid Integration Laboratory website. You can go through that. We have a certain projects also under our supervisor. You can contact them. And coming to this course, that will be very helpful. If you
Yes, sir, yes, sir.
if you have a power system background and want to work
Yes, sir,
and
yes, sir.
explore that in this
Yes, sir,
related field, this will be very
Yes.
helpful. And for the project also, you have to go to the this professor's website for the research project. For seeing for that, suppose there is a project under certain professor, so you have
sir.
to go to certain IIT website. Then you have to search
Yes,
that what professors are working on that field, and in that
Yes, sir.
also you see that what upcoming project is there. And you can mail the professor also that sir,
Yes,
also I want to work under you as an intern.
I already sir mailed to 2 or 3 professors in the last 2 days, but there is no response yet, and I don't think so they are having any project currently. We don't know how we can know about this, they are having the project or not in their labs.
Yeah, you should join the LinkedIn. Mostly professors
I am there,
post.
I am there.
Mostly and you should join with these professors also, because they post their research these projects which is upcoming projects or ongoing projects hirings on this and this LinkedIn pages also, and the personal pages, this institute pages also, and this LinkedIn pages also. And for my project, my group and my lab, I have showed you that is the Grid Integration Laboratory. We also have certain project. I'm not marketing, but there is some projects are there. You can try that.
Thank you sir, thank you very much sir for this great knowledge sir. Thank you sir, God bless you.
Welcome, Imtiaz. Any other doubt?
Thank you.
Any other doubt, anyone? Otherwise, I will stop this session. Any other doubt?
No, sir, thank you.
Welcome, Arshia. Welcome. Any other? Okay, guys. I'm stopping this session. Thank you very much for joining and making this interactive session. Thank you very much. Thank you very much.